Now welcome back to Master Academy of Mathematics. It is the next continuation topic of multiple integrals. So in the last video sessions we completed your evaluation of double integral. Now I am entering into triple integral. This triple integral, it is the extension of double integral. Almost it is satisfying all the properties of double integral. Additional term is there, one more integral, one more variable. Supposing that corresponding to a function f of x comma y comma z, it is a function involving three variables x, y, z. The triple integral directly you can write like this. It is a triple integral. You just write f of x comma y comma z. It is with respect to x, y, z. Only the thing is, in order to find out such type of triple integral, you need to identify the integrals first. So it is related to x integral, y integral and z integral, that entirely based on the order of dx, dy, dz. As I told you in the last session, you decide this dx, dy, dz, its opposite order is nothing but it is the z integral, it is the y integral, it is the x integral. So depending on the order of the dx, dy, dz, you can decide the nature of the integral and directly you find out integration and substitute the limits. So you will have an idea while taking certain problems. Okay. Now let us take one example. Evaluate triple integral. The limits are given 0 to 1, 1 to 2 and 2 to 3. Integrand is x, y, z, dx, dy, dz. First you look onto the limits. Are all the limits real numbers or involving any variables? No variables are there. So directly you can think about that order dx, dy, dz. The same problem you can write it as. What about that dx, dy, dz? You just reverse it. Reverse means this is your z integral 0 to 1. What about the next one? Y integral 1 to 2. The next one is x integral 2 to 3. So it is of xy, z, dx, dy, dz. Remember, in order to do the integration, start with this one. What about this one? Dx. That means you are first doing integration with respect to x variable. That means the first two integrals you are keeping as it is and find out the integration with respect to x. So y, z, it is a constant term. X integration is x square by 2. The limits here it is 2 to 3 and still we have dy, dz. Right? First you do the simplification. Z limits 0 to 1 and here y limits 1 to 2. Yz you are keeping as it is. What about that upper limit? It is 9 by 2 and 4 by 2. So 9 by 2 minus 4 by 2. It is directly you are getting 5 by 2. It is of dy, dz. So corresponding to this, 5 by 2 it is a constant term. Now you are writing the first integral 0 to 1, integrate with respect to y variable. So z it is a constant term. Y integration is y square by 2. You are substituting the limits 1 to 2 and still we have here it is dz. So 5 by 2 it is as it is. Integral z equal to 0 to 1 and substitute your z as it is. What about upper limit now? 4 by 2 minus 1 by 2. You are getting the answer is 3 by 2 and still we have here it is dz. Okay, now this 3 by 2 it is a constant term. If I take it to the out of the integral, so 15 by 4. Now you are doing the integration with respect to z. It becomes z square by 2. The limits here it is 0 to 1. Substitute here it is 15 by 4 as it is. Upper limit 1 by 2 and minus lower limit is 0. So you are getting 1 by 2. Final answer is 15 divided by 8. That is how you are finding the triple integral corresponding to the given problem where the limits are belonging to only real numbers. Now let us have another triple integral problem. It is a triple integral 0 to a, 0 to x and 0 to x plus y. Integrand is e power x plus y plus z of dx, dy, dz. So here look at the limits. They are not the real numbers but represented in variables. So in that case, don't consider this dx, dy, dz. Look onto the integral limits. First you select the highest variables in the limits. So where you are getting highest variables? So look at the three integrals. The third integral you are getting maximum number of variables. So this is nothing but first you are selecting. Already the variables are there x, y. So these are the limits corresponding to the opposite. What is the opposite variable? Which is nothing but z variable limits. Coming to the next, already z is over. We have only the two variables x and y. Think about this integral. This is involving x variable. That means its opposite is nothing but y variable. So already y z is over. Automatically you can say that this is x integral. Are you understanding this? Out of these three integrals, you are selecting one integral which is having more number of variables. So z integral, y integral and x integral. So that I can write like this. It is x integral 0 to a. It is y integral 0 to x. It is the z integral 0 to x plus y. Now it is e power x plus y plus z. It is of dx, dy and dz. Now first, what is the integration? First you start with your, don't look at this one. You are first concentrating on this. First you do the integration with respect to z variable. So the first two integrals 0 to a, here it is 0 to x. Do the integration with respect to z. In that case e power x plus y, it is a constant term. We have only e power z. E power z integration, again e power z. So limits 0 to x plus y, we have here it is dx dy. So directly x equal to 0 to a, it is 0 to x e power x plus y. If I write the upper limit, e power x plus y and minus, write z equal to 0, e power 0 is nothing but 1. So we have here it is dx dy. Now you are keeping that x equal to 0 to a, taking your second integral, it is with respect to y. But first you make the simplification 0 to x. If I make the multiplication, it becomes e power 2x plus 2y minus of e power x plus y. It is of dx dy. Now you find out the integration with respect to y variable. 0 to a, it is as it is. Integrating with respect to y, that means e power 2x constant, e power 2y integration e power 2y divided by 2 minus e power x constant, e power y integration is e power y. So substitute the limits 0 to x. Now it is x equal to 0 to a. I am just substituting in the place of y variable e power 2x. This is also e power 2x by 2 minus upper limit e power x into e power x, and coming to the lower limit y equal to 0. So e power 0 is 1. You will be having e power 2x divided by 2. Already minus is there, so plus, substitute y equal to 0. You will be having e power x, and still we have here dx. Now you integrate with respect to x. So that directly e power 2x is nothing but e to the power of 4x. So already 1 by 2 is there, e power 4x divided by 4. This is the integration. Minus e power 2x divided by 2. Coming to this, minus 1 by 2, e power 2x divided by 2 plus e power x, and directly you substitute your x limits 0 to a. So when I go to the substitution part, it becomes 1 by 8 into e to the power of 4a minus 1 by 2 e power 2a minus 1 by 4 e power 2a plus e power a. Upper limit is over. Coming to the lower limit. What is the lower limit? X equal to 0. If I write x equal to 0, you will get minus 1 by 8. Similarly, plus 1 by 2. And here also plus 1 by 4. And here it is minus 1. So just you do the simplification. You will get the final answer of your given triple integral. Now let us have certain exercise problems here. Triple integral minus 1 to 1, 0 to z, x minus z to x plus z of x plus y plus z of dx dy dz. First thing is nothing but decide the integrals first. Selecting the maximum means here two variables are there. So x z means its opposite is nothing but it is y integral. And already y over means we have only x and z. So here it is z is present means it is the x integral, and the rest is nothing but here it is z integral. Just you identify it, do the integration one by one, final answer is 0. Coming to this, integral 1 to e, integral 1 to log y, integral 1 to e power x, log z, dz, dx, dy. Forget about this order. First you select the nature of the integrals. So how to calculate this nature? Look at maximum. Where you are getting maximum? This is involving only 1. Here also only 1. These are the real numbers. So when you are getting equal number of variables, better in that case you follow this order. What is this order? dz, dx, dy. It's opposite. This is the y integral. The next is x integral. The next is nothing but it is z integral. So just you do it and you can find out the answer. 1 by 4 e square minus 8e plus 3 plus 13. But look at log z integration. That log z integration can be taken as log z into 1. So I just give you one principle. Log x dx integration is nothing but it is x into log x minus 1. That is the principle for integral of log x. So based on that you can directly find out the answer, and that is your final one. Similarly, one more. Integral 0 to 1, integral 0 to 1 minus x, integral 0 to 1 minus x minus y, e power x dx dy dz. Here also selecting the maximum, two variables are there. So it is related to the z variable. The next is nothing but y, and here it is x. So based on that you can find out the answer. 1 by 2 into e minus 3. Similarly, the next one, 0 to log 2, 0 to x, and 0 to x plus log y, e power x plus y plus z, dz dy dx. So in that case, only the thing is, the maximum is two variables, so definitely it is belonging to z. And this is automatically y, here it is nothing but x. So answer is 8 by 3 log 2 minus 19 by 9. Similarly, this was given already in the previous examination paper. Integral 0 to log 2, integral 0 to x, integral 0 to x plus y, e power of x plus y plus z, dz dy dz dx. Same procedure. This is z integral, and here it is y integral. This is your x integral. One by one you do the integration, and the final answer is 5 by 8. So this is how you are finding the triple integrations corresponding to the given problems. With that, triple integration part is closed. In the next video session, we will take one important topic, which is nothing but changing into polar coordinates. So have a good day.